Welcome to section 2.3. We're going to be talking about division with polynomials. So before we even get into the division algorithm, let's go back and remember long division from elementary school. So let's say we have 538 and we're dividing that by 3. So remember, you want to see for the first number, 3 goes in the 5 once. So the 1 goes up top, 3 goes on the bottom, and what we're doing is we're subtracting that number. So it's 5 minus 3, and we bring down the 2. Bring down the next number, 3. Now, how many times does 3 go into 23? 7 times. 7 times 3 is 21, so we put the 21 down there, and we're subtracting. 23 minus 21 is 2. Bring down the 8. 3 goes into 28 9 times. 9 times 3 is 27, and we're subtracting. That leaves us with a 1. Now, without going in the decimals, that 1 at the end is our remainder. So how we commonly write this is we ended up with 179 and 1/3, where the 1 goes over our divisor of 3. Another way you could write this is that you're going to end up with 179 plus 1. Or 3 times 179 plus 1. And that's how you could write that number. That's another way to write it. So bringing that back to the division algorithm, the function is the divisor times the quotient plus the remainder. Or we'll more commonly see it as the quotient, what we get from our division, plus the remainder over what we divided by. So we're going to go through a long division. Now we're dividing by x minus 2, so x minus 2 goes on the outside. Give yourself plenty of room to write this down and try to write as neatly as possible. 6x cubed, then we have to go to negative 19x squared, plus 16x minus 4. We're going in standard form, making sure that nothing is missing. Now, all I care about is the first number, the x and the 6x cubed. X, to become a 6x cubed, I have to multiply by 6x squared. Now, I'm dividing by a binomial, so I'm going to count over 2 places. So 6x squared goes up there, and you can see it's right above the x squared. Not a coincidence. I'm going to distribute the 6x squared to x minus 2. I get 6x cubed minus 12x squared. Now remember, with long division, we subtract. Use your grouping symbols. We're subtracting the whole thing. To subtract properly, we distribute the negative. Change all of the signs. So the 6x cubes cancel. Negative 19x squared plus 12x squared is negative 7x squared. Now I bring down my 16x. Once again, I only care about the first terms. I need to make x a negative 7x squared. To do that, I'm going to multiply by negative 7x. See how the x's are nice and lined up? Distribute the negative 7x. I get negative 7x squared plus 14x. With long division, we're subtracting the entire polynomial. Change all of the signs. Distribute that negative. The x squareds cancel. We're left with a 2x minus 4. I only care about the first terms. X to become a 2x, I'm going to multiply by a positive 2. So I distribute, I get 2x minus 4. Remember, we're subtracting the entire polynomial. Use your grouping symbols and then change every single sign. And when we do that, we have a remainder of 0. So this divided evenly. So we ended up with 6x squared minus 7x plus 2. That's our quotient. That's Q of x. So if we wanted to write this in factored form, our divisor was x minus 2. That's d of x. And our q of x was 6x squared minus 7x plus 2. And that was from right above, where you could write it as d of x times q of x. That's our function. Now this could be factored, so we could write our function f of x equals x minus 2. When you factor that quadratic, you end up with 3x plus 1 and 2x minus 2. That's one of the features of long division. It helps us factor. And we'll learn other ways to do this as well. But this is long division. Let's go to problem number 2, another division problem. We're divided by x plus 1. So x plus 1 goes on the outside. On the inside, x squared plus 3x plus 5. No terms were missing, no placeholders needed. Only care about the first term. X to x squared, I'm going to multiply by x. Notice how my x's are lined up. So I distribute the x, we get x squared plus x. We're subtracting the entire polynomial. Distribute the negative, change all of the signs. They cancel. We're left with 2x plus 5. X to become a 2x, we're going to multiply by a positive 2. Distribute the 2, we get 2x plus 2. Don't forget, we're subtracting, so distribute the negative, change all of the signs. The x's cancel, and we're left with a positive 3. There's our remainder. So you might see it written as x plus 2 plus our remainder of 3 over x plus 1. That's the way we're commonly going to write it. Or you could write it in that factored form. X plus 1, the divisor, the quotient x plus 2 plus the remainder of 3. So that's the d of x, the divisor, q of x, the quotient, and r of x, our remainder. So that's another way to write this division answer. They both have their pros and cons as writing. Let's do another long division. X cubed minus 1 plus, or divided by x minus 1. So x minus 1 goes on the outside, and on the inside, here's where it's a little bit different. X cubed, but we don't have an x squared, so we're going to put plus 0x squared. We don't have an x, so plus 0x minus 1. We needed the placeholders there. Only care about my first terms. X to x cubed, I'm going to multiply by x squared. When I distribute, I get x cubed minus x squared. Be very careful of your signs here. With long division, we subtract. Distribute the negative, change all of the signs. The x cubes cancel, so we're left with 0x squared plus 1x squared is x squared. And then we bring down the 0x as a placeholder. X to x squared, we're going to multiply by a positive x. So it gives us x squared minus x. With long division, we subtract, distribute the negative. So change all the signs. So we're left with the x squareds cancel, x, and then minus 1. X to x, we multiply by a positive 1. So we get x minus 1 we distribute. And don't forget, you're subtracting, distribute the negative, change all of the signs. And they cancel. So our remainder is 0. So we end up with x squared plus x plus 1. That's the way we could write it. Or x minus 1, our divisor, times our quotient x squared plus x plus 1. We had no remainder. That's why we didn't have to account for it. Let's do one more division problem, long division, then I'll show you another way that's a little bit quicker. So we have x squared plus 2x minus 3 on the outside, and on the inside, 2x to the 4th plus 4x cubed minus 5x squared plus 3x minus 2. Nothing was missing, so we didn't need any placeholders. Now, we're dividing by a trinomial, so we're going to go over 3 places this time. Once again, x squared to 2x to the 4th, I'm going to multiply by 2x squared. When I distribute the 2x squared, I end up with 2x to the 4th plus 4x cubed minus 6x squared. With long division, we're subtracting. Distribute that negative. Change all of the signs. They cancel. Cancel, and then we're left with x squared. I'm going to bring down my plus 3x, and while I'm at it, I'm going to bring down my negative 2. Now, x squared to x squared, I'm going to multiply by 1. So I'm going to put that with my constants column. So I have, for a placeholder, a 0x here. It doesn't exist. We don't have any x to the first term. But we do have that positive 1 at the end. So just keep everything lined up. I'm going to distribute the 1. X squared plus 2x minus 3. With long division, we are subtracting. Change every single sign. The x squareds cancel. X plus 1, that's our remainder. So you could write this as 2x squared plus 1 plus the remainder of x plus 1 over x squared plus 2x minus 3. Another way you could write this, our divisor, x squared plus 2x minus 3 times the quotient of 2x squared plus 1 plus the remainder of x plus 1. Divisor d of x, the quotient q of x, and r of x, the remainder. Multiple ways to write the same thing. Like I said, we're going to more commonly see them written like that. Okay, I'll see you in the next video, and we're going to talk about what's called synthetic division.